method to solve quadratic inequality. If you don't want to use the concept of quadratic equation, there is another way to solve quadratic inequality. Let's have the same example. X squared plus 7x plus 12 is greater than 0. First, we need to understand that we can factor out x squared plus 7x plus 12 as two binomials, x plus 3 and x plus 4 is greater than 0. Now, since you have the idea that this should be greater than 0, it can have two cases. There will be two cases. Let us talk about the first case here. Case number 1. The first case will be x plus 3 times x plus 4. It should be x plus 3. You're saying you now separate them. It can be x plus 3 is greater than 0. And then the other one, x plus 4, greater than 0. Because if you will think of the idea that if both of these are positive, positive times positive is positive. So all positive numbers are greater than 0. Therefore, this is the first case. X plus 3 is greater than 0. X plus 4 is greater than 0. And we solve it by transferring. We have x is greater than negative 3. The other one, transfer 4. X is greater than negative 4. This is the first case. While for the second case, case number 2, it can be x plus 3 is less than 0 and x plus 4 is less than 0. Why? Because if x plus 3 is less than 0, let's say, for example, a negative number, and then this one is also less than 0, a negative number, negative times negative is positive. And it will still give us a number greater than 0. So this is the second case. So we write x is less than negative 3 and x is less than negative 4. Okay, now, we will select between the two here in case 1 and between the two here in case 2, which will be suitable to be graphed. Now, here, x is greater than negative 3. If you draw a line, here, I will draw a number line. And then, I will place here 0. To the right are positive, to the left are negative. Okay. X is greater than negative 3. So here, this is negative 3. If x greater than negative 3, to the right. And then x greater than negative 4, it should be here. Negative 3, negative 4. Between the two, we will use x should be greater than negative 4. And then, sa case 2, if you have x negative 3, which is here, x is less than. Okay, if a number is less than negative 3, it's also less than negative 4, right? Correct? If a number is less than negative 3, it's also less than negative 4. Therefore, it gives us the idea that we choose here, between the two, we choose x is greater than negative 3, and then x is less than negative 4 for the two case. We have x is greater than negative 3, and then here, x is less than negative 4. And we plot them, negative 3 here, and then negative 4 here. And then same way, a while ago, you need to shade to the right and shade to the left to show that those are the solutions for this inequality. So we need first to find these two. X is greater than negative 3 and x is less than negative 4 in order to easily graph the inequality. Here we don't actually find true or false statement. Instead, we simply understand that here, x is greater than negative 3. And then the other one is x is less than negative 4, as shown in the graph. Okay, a while ago, there's a question. There's a question a while ago. What if there's one positive and one negative? So let's have an example for that. A quadratic inequality wherein there is one positive and one negative answers. Okay, can you see the equation that I have written on the board? Clear pa ba yung video natin? Hello? Okay. Our second example is the inequality 2x squared minus 5x is less than or equal 3. Okay. First step, we need first to rewrite this inequality in the standard form. Because as you can see, the value of c is on the right side. It should be written to the left side. So we write it as 2x squared minus 5x minus 3 is less than or equal to 0. Okay, after that, we can now proceed with the next step of rewriting it to an equation to easily solve the inequality. I will write 2x squared minus 5x minus 3 is equal to 0. Apply factoring. 2x squared will be 2x times x. And then 3 is a prime number. It only has two factors, 1 and itself, or 1 and 3. To decide where to place 1 and where to place 3, we need to place 3 here and 1 here because there's a negative sign for 3 and negative in 5. We should write here plus and then minus. To check that all numbers are placed correctly as well as the sign, we need to apply FOL method. Outer terms 2 and negative 3 equals negative 6, and then 1 times x is x. And when we add them, negative 5x. Correct. The placement of the numbers as well as the signs are correct. Next, apply zero product property. We have 2x plus 1 is equal to 0. And then x minus 3 is equal to 0. Transfer 1 to the other side. 2x is equal to negative 1. Divide both sides by 2. X is equal to negative 1 half. And we write this back to inequality. The other one, x is equal to 3. X is less than or equal to 3. So we obtained here the two results, negative 1 half and positive 3. Okay, so we have negative 1 half and positive 3. This is the case wherein there's one positive and one negative. The next step, we now need to graph, to draw a number line. So one negative, so I will place here 0. And then if this is 0, to the left is negative numbers. To the right are positive numbers. Let us first test a number. So since my fraction, negative 1 half is here, between 0 and negative. Let us first test a number which is the answer itself. Let us try with negative 1 half. Let us test negative 1 half. Test negative 1. To do that, replace negative 1 half in the inequality. 2x squared minus 5x is less than or equal to 3. All x will become negative 1 half. Apply exponent first before multiplication. So 2. The square of negative 1 half is positive 1/4. The product of two negative numbers is positive. Whole number and fraction, numerator times numerator, calculate in denominator, less than or equal to 3. And then multiply also here. 2 times 1/4 is 1/2 plus 5 over 2 less than or equal to 3. 1 plus 5, 6. 6 divided by 2. 6 divided by 2 is equal to 3. 3 is less than or equal to 3. Because there is the symbol equal below, less than or equal, we will consider this as true. That is true. Because there's equal. From the very beginning, the given inequality contains less than or equal. That means testing negative 1/2 will give us a true statement. That only means that you need to put a small circle in 1/2 and then shade that circle. Shading the circle indicates that negative 1/2 is part of the solution. Unlike in the first example, using the solution and then we obtained false, that's the reason why we do not shade the circle wherein the solution falls. But this time, that is true, we need to shade negative 1/2. Okay, next, let us test 3 from the solution. Let us test 3. Same, replace 3 from in the original inequality. 2 times 3 squared minus 5 times 3 less than or equal to 3. Apply the exponent first. The square root of 3 is 9 minus 15 less than or equal to 3. 9 times 2 is 18 minus 15 less than or equal to 3. 18 minus 15, 3 less than or equal to 3. It is also true. Same, just like here. Therefore, you need to put a small circle in 3 and shade that also. You need to shade that part because it appears from the solution that it is true. That means 3 is a solution, is part of the solution. Now, we need to draw the lines that indicates, aside from negative 1 and 3, which other numbers are solutions. Because hindi lang negative 1 and 3. All other areas can be solution. To do that, you need to keep on trying. We need to test 3 more numbers. Which numbers? First, the number which is to the left of negative 1/2, this area. Because if this is true, we need to shade this part. Another, the number which is between negative 1/2 and 3 here. We need to choose one number here. And then lastly, we need to choose another number here to the right of 3. Okay, let me start with a number to the left of negative 1/2. So I will erase, since we don't have any area left, I will erase this part. I will now test one number, choose any number which is located to the left of negative 1/2. I will test, of course, you need to choose the easiest one. Use negative 1. Okay, you may choose any number as long as it is to the left of negative 1/2. It can be as far as negative 100, but for the sake of easy computation, use negative 1. So we use the original. So the original inequality, negative 1 squared minus 5 times negative 1 less than or equal to 3. Square negative 1, positive. Multiply 2 negative, positive, less than or equal to 3. 2 times 1 is 2 plus 5 less than or equal to 3. 2 plus 5, 7. 7 is 7 less than or equal to 3? The answer is false. Okay, since this is false, do not shade the area to the left of negative 1/2 because it is false. Do not shade the area to the left of negative 1/2. Next, let us test a number which is located at the middle of negative 1/2 and 3. Choose one number at the middle. I'll choose 0 for easy computation. You may choose 1 or 2, but to make it easier, or the easiest way, choose 0. Because 0, 1, and 2 are all located between negative 1/2 and 3. I will choose 0. Use the original inequality. 2 times 0, or the square of 0 is 0 itself, 0, plus 5 times 0, 0, less than or equal to 3. 0 plus 0, 0. Is 0 less than or equal to 3? Yes, that is true. Okay, since we obtained this fact or proof, we can now shade this part or draw a line here. Okay. Placing a line here, okay, in your activity, if you can use other colors, it is much better to use other colors. As for example, you already used black pen to show that you have drawn here another line to show the solutions. Use blue pen or crayons to show that this portion, this area are all solutions. If you shade this area from -1/2 up to +3, that only shows that all numbers located here are solutions because of this proof. Lastly, you need to test last number to the right of 3. A number to the right of 3. And then that is 4. Okay? The easiest number to use is 4. So test 4. 2 times 4 squared plus 5 times 4 is less than or equal to 3. The square of 4, 16. The product of 5 and 4, 20. Less than or equal to 3. 2 times 16 equals 32 plus 20 less than or equal to 3. 32 plus 20 is 52 less than or equal. Obviously, that is false. Of course, 52 is not less than or equal to 3. It is false. That means you will not shade the area to the right of 3 because that is not a solution. You'll only shade from -1. Finally, we can now write a solution set. Solution set. This will summarize the statement that will give us the answer. So set of all x such that x is less than 3, but it is greater than -1/2. This is a solution set. So you will place x at the middle. So x is less than 3 because that means the numbers which are less than +3. But x are numbers, and since may equal, you need to place equal sign sa baba to include 3 and -1. So the solution set would be set of all x such that x is less than or equal to 3 but greater than or equal to -1. Or it can also be read as x, set of all x such that x is less than or greater than -1/2 but less than +3. Again, it can be read as set of all x such that x is greater than or equal to -1/2 but less